Okay, here's a couple more examples for you. Again, it's the same template, same steps to follow. Always look for the GCF first. Count the number of terms, 2, 3, and 4 terms. Try each one of these. Formulas are given there. And then, of course, the last step is always super important. Make sure you check to see if it factors out any further. All right, here we go. First step in factoring, we're going to look for that GCF. Now, again, I'm not going to write the factored out GCF out of each of those. I'm just going to let you know that it's got a GCF of x. Left over is x to the 6th plus 2x to the 3rd minus 3. Okay, it's a trinomial. It doesn't look like it's supposed to, right? It's not x squared plus 2x minus 3. But if it were, we could easily factor that out, right? X squared plus 2x minus 3. That's an easy one. That's a nice double bubble. Got our x out here. Got to multiply to negative 3, but add to 2. That would be positive 3 and negative 1. Okay, x plus 3, x minus 1. So this guy over here is going to factor into the exact same things. It's going to be x plus 3 and x minus 1. But this number right here, it wasn't a 2, it was a 6. And this middle one was half of that, which means our powers here are actually supposed to be 3's. So factoring them together, so this would actually be factored as x cubed plus 3 and x cubed, it's not an x, that's an x, minus 1. Now the next step is to look to see if they factor any further. So looking at just this one on the left, I go, oh, it's 2 terms. Is it a difference of squares? No, this says x cubed, so it can't be the difference of squares. Plus it's a sum, not a difference, right? So sum of cubes. Well, is there a cubed root of 3? No, there's no cubed root of 3. It is not 1 times 1 times 1. There is no perfect cubed root of 3, so this one doesn't factor any further. So we're just going to bring that down, and that's going to be his part in the answer. Okay, so x cubed plus 3. I don't know what's going on with this stupid eraser thing here, but I'll try to ignore it if you will. All right, inside here, though, we've got x cubed minus 1. It's obviously cubed, so we want the cubed root of x cubed. That's x. And then the cubed root of 1 is just 1. So in our formula, we needed our a, that's an x, and our b. When we factor that out, it's got a binomial, 2 terms, and a trinomial. In the first spot is an a, or x. In the second spot is b, or 1. And the sign is always the same as what you started with. Okay, the next part, the trinomial, has a squared, the opposite sign, so plus, and then an a times a b, always plus a b squared. Okay, simplifying that out, we would have x minus 1, x squared plus x plus 1, and then this guy. Okay, am I done? No, wait a minute. There was a kid in the back seat. Don't forget him. And that would be factored completely. All right, this one. Again, first step is always to start with a GCF. So I'm looking at that. The GCF would be 3x to the 5th. Left over here, I've pulled out the 3 and I've pulled out 5 of the 7 x's. So there's an x squared left over, minus. Out of the 75, I've pulled a 3 and I've pulled those x to the 5ths out. Again, if you need to see the full write out, you can write these out, right? Expand them all the way out, circle what they have in common. That's what it is. Okay, looking at what's left over, this one's nice and easy. 2 terms. There's a minus in between, so I'm looking for the difference of squares. Square root of x squared is x. Square root of 25 is 5. What? Who put that there? Who took that away, I mean? Okay, so we'll have x and 5, x and 5. They're twins, but not identical. And then don't forget the kid in the back seat. That was Kate compared to the last one, huh? Okay, 4 more terms. Still, first step is to look for that GCF. If you go through all the terms, there's an x in all of them. So x will be a GCF. I've got x to the third minus x squared plus 9x minus 9. Those are my leftovers. Okay, 4 or more terms. We're going to do it by grouping. Group these two and those two, and you look for GCF in each one. Right here, they have x squared in common. Leftover is an x minus, now I took all the x squareds out. Superhero 1 comes in. Dun, 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 I'll hold that place. Okay, that one's factored. Plus GCF between 9x and 9 is just a 9. Leftover is x minus, dun, 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 there's the 1. Oh my gosh, what a coincidence. Look, they both have an x minus 1 there, which means that can be pulled out like a GCF. And then next to that, you write the leftovers. So I've got an x squared left over here and a plus 9 left over there. All right, here in the yellow, 2 terms, it's a minus in between, but are there square roots? No square roots, so that's going to stay exactly as is. Okay, next one is x squared plus 9, 2 terms. It is not minus in between, so it can't be difference of squares. Is it cubed? No, that's silly. It's just x squared. So that's x squared plus 9. Kid in the back seat, don't forget him. That becomes your final answer right there. So 3 more examples. One of them was as hard as it will get. These 2 are pretty basic for what they look like. You are welcome.